This is Code and Architecture with Jukka. Practical coding, smart design, and technology that actually gets things done. Today's topic is let's build a simple RAG server. RAG or Retrieval-Augmented Generation is the technique that connects language models to external data. So instead of guessing, the model retrieves real information from your own sources before generating an answer. In this video, we will start a project to build our own simple RAG server. Not a full-blown product, just a proof of concept to understand how the pieces fit together. All the links and resources I mentioned are in the video description so you can follow along. And before we go deeper, if you enjoy this kind of hands-on tech content, hit like and subscribe so you won't miss the next build. Let's start by constructing the basic architecture view of our system. At the front, we have the chat client. This is the front end or user interface of our system. It's what the user interacts with to write prompts and view responses. The chat client's role goes beyond just sending a message. It also handles chat context. That means it decides how much of the previous conversation history to include when sending the latest query to the backend. Once the client sends it the input, it reaches the LLM or large language model. The LLM processes that input and generates a response based on its training data and internal knowledge. However, there's a limitation here. The LLM can only respond to what it has been trained on. If the model was trained on data from 2 years ago, it won't know what's happening today. And if the question relates to private, proprietary, or corporate data, information outside its training corpus, it simply can't access or reason about it. So, this is exactly the challenge that motivates RAG architecture. It helps us connect the LLM to real, current, and often private information sources, bridging the gap between static model knowledge and dynamic real-world data. To solve this, we inject our simple RAG server between the chat client and the language model. Instead of the client sending its prompt directly to the LLM, it now sends it to our RAG server first. The RAG server's job is to enrich those requests. Before passing anything to the LLM, our server appends new, relevant information from external sources, such as up-to-date documents, private knowledge bases, or proprietary data. This way, the model gets both the user's prompt and up-to-date custom data context. As a result, the LLM can generate responses that are both accurate and grounded in the most current and relevant information available. Now, let's look closely at what we actually need to implement. First, our chat client needs a way to talk to the server. To keep things simple for integration, we will build an API layer that's compatible with the OpenAI API. So developers and tools already familiar with the OpenAI ecosystem can connect without major changes. Next, we have to implement information retrieval. The main goal is to search by vector. In vector search, we take the user's query, calculate its vector embedding, and use it to search a vector database for chunks of content with similar vectors. Essentially, pieces of text most closely related by meaning. Alternatively, there's the classic search method, keyword or query search, like traditional search engine operating over document database. Both approaches are valid, but vector search provides more semantic, context-sensitive results. However, before we can retrieve any information, we need to make it available in the first place. That means we have to do document extraction, reading from various file formats, whether it's PDFs, Word documents, or websites. Once we pull the content out, we split it up into chunks, manageable pieces of text that logically belong together. The next step is to generate vector embeddings for each chunk, turning them into search-ready numerical representations. We then save both the documents and their chunks to the database, making them available for fast retrieval. Our pipeline is almost complete, but there's one last key piece missing: document management. Why? Because while document might be valid today, tomorrow the information could change or need redacting. Good document management lets us update, remove, or revise content reliably, ensuring our RAG server always reflects the latest, more accurate information. So now we have solid understanding of the basic architectural components in our RAG server. Next, let's clarify what we want to focus on building and what we will avoid. In this architecture overview, you will see some components marked in red, yellow, and green. Red marks parts we don't want to work with, or perhaps because they are too complex, out of scope, or we simply don't need them for our proof of concept. Yellow components are the things we would work with, but for now we would rather leverage existing solutions. Green is our core focus, areas we need to implement ourselves. For our document and vector databases, we are using existing battle-tested software. No need to reinvent the wheel here. For embeddings, we are choosing open source models, which gives us flexibility, speed, and control over how the text is converted into vectors. When it comes to document extraction and chunking, we could potentially write our own library or custom logic, but for first iteration, we will stick with ready-made components that handle the heavy lifting for us. So what's really left for us to implement and forms the core of our solution? Three things: the OpenAI API-compatible interface, the information retrieval logic, and the document management layer. Building and integrating these components is where our development effort is focused, and it's what will tie together the whole RAG architecture for our server. Finally, let's take a look outside the boundaries of our RAG server and clarify what we are not building. First, working directly with the language model is out of scope for us. While it's technically possible to run models inside our application using the right libraries, that would add significant complexity. For this project, we are treating the LLM as black box, something we call as a service, rather than something we run or modify ourselves. The other area staying out of the scope is the chat client itself. Sure, if we build our own chat interface, we could optimize things like how chat history is managed or passed with user queries, but for now we are focusing purely on the server side. We might revisit the client later for optimizations or tighter integrations, but that's a future consideration, not today's problem. Keeping these components off our plate lets us direct our energy and time into building the core, critical layers of our RAG server. So, how are we going to feel all of those components in our architecture? When selecting software, I had a few ground rules. It needs to be open source, widely adapted, and it ideally have a strong corporate backer to ensure longevity, support, and ongoing improvements. For the chat client, we will use ChatBox. It's flexible, open source, and easy to integrate with various backend systems. For the language model, I have chosen the IBM Granite series. The big advantage of Granite is that it includes small models specifically trained for Retrieval-Augmented Generation. They reliably follow instructions and can produce structured outputs like JSON when needed. Choosing the right LLM really matters. Not all models handle RAG workflows equally well. So picking one design for this helps ensure strong performance. For our database backend, we are going with OpenSearch, an open source fork of Elasticsearch, now backed by AWS. It lets us perform both keyword and vector search, and it's known for easy scaling and robust enterprise features. When it comes to document extraction and chunking, we are using Docling. Docling is an IBM research project that supports reading most popular document formats, can handle images and tables inside documents, and comes with built-in chunking capabilities. To create embeddings for our chunks, we will use EmbeddingGemma from Google. It's an open source embedding model that's efficient, accurate, and easy to run. perfect for turning text chunks into search-ready vectors. Once the vectors are created, we save the chunks and their vectors to OpenSearch, making them ready for semantic and traditional retrieval in the server. Every component has been selected for openness, reliability, and future-proofing, so our simple rack implementation will be easy to maintain and extend as the system evolves. Now we have arrived at the blueprint of our project. When we talk about what the simple rack server is actually going to implement, we can narrow it down to the three components: an OpenAI-compatible interface, robust document management, efficient information retrieval. These are the key pieces we will build ourselves, integrating with the best open source tools and services for everything else. By focusing on these areas, we keep our server architecture clean, modular, and easy to scale or adapt. The OpenAI API layer delivers compatibility and ease of use. Document management ensures our content is always up to date, valid, and ready for retrieval. Information retrieval powers semantic search, so our servers delivers meaningful, grounded answers to every query. With these pillars in place, our simple rack server will be practical, extensible, and ready for real-world tasks. Alright, let's take a look at the GitHub project, Simple Rack Server. I built this project using Java, Spring Boot, and Spring AI. Alongside the application code, the repository includes Docker Compose setup that spins up all the required infrastructure components. So to run the project, you don't need to manually install OpenSearch, Docling Serve, or even Ollama. All you need to do is bring up Docker Compose and then start the Spring Boot app itself. If we explore the project structure, it's made a multi-module project consisting of two sub-projects. The first one is Simple Rack NLP. This module contains code related to traditional NLP, things like detecting languages, extracting nouns, and the author text analysis functions. It's a bit of experimental at this stage since I'm exploring simple yet efficient ways to pre-process queries and text before sending them to the LLM. The second one is Simple Rack Server. This is the main Spring Boot web application, the heart of the project. It implements the key pieces of our architecture: an OpenAI API-compatible chat interface, document management, and information retrieval. The code base is still a little messy, as you would expect from proof of concept, but once everything stabilizes, we can clean it up and refine the structure. If you're curious about how the server actually works, start by looking at a few key classes. First, chat service located in the chat packets handles incoming chat messages and coordinates the LLM calls. It is the entry point for the OpenAI compatible chat endpoint. Next, document service in the service package manages document ingestion. It saves the uploaded files into the content storage and then creates corresponding documents entries to OpenSearch, storing both metadata and searchable content. Finally, search service also in the service package manages querying operations. It provides facilities to search OpenSearch using both term-based queries and vector similarity search, supporting hybrid retrieval that combines traditional keyword matching with semantic vector search for improved relevance. These are excellent entry points to understanding the system internals. Okay, let's start the project. I have already built the Docker images on my machine, so this will be a quick one. However, if you're doing this for the first time, please note that building the images can take a while. So just be patient and let the Docker do its thing. Alright, and now our infrastructure is up and running. Both OpenSearch and Docling are live and ready. Next, let's start our Spring Boot application. Running it is just a matter of running the Maven command, and once it's up, we should see the Spring Boot banner appear in the terminal. And there we go, our app is up and running. The infrastructure is active and the services are connected and everything is ready to start interacting with the system. So with the backend running and the environment ready, we can now move on to using the application. Good, and let's look at our Swagger. So in here in Swagger, we have exposed all of the internal API endpoints. This is very handy, especially when we are doing testing. We might want to, in the future, separate these into external and internal, and maybe there is something that we would, just get rid of completely. Now let's check that our database is empty. Yep, no documents loaded at all. So the next thing in our testing is that we could upload a document there and chunk it. So let's add a document. I have a document concerning personality testing. It's handy because it has a lot of acronyms inside it, which is a little bit difficulty for the vector search to handle, so it's nice. So, and in here we can see already that the Docling is handling, so we use the Docling async method, so we loaded the document to Docling and now we are pulling from Docling when is the document actually ready, and when the document is ready we will get the results of the operation. So let's wait for a few minutes. Good. I think that the document might be ready, so we will check from our document interface what is the state of the document. Okay, it's still processing. So we have to wait a little bit more on the Docling to get ready. No problem with that. And let's try it again. Is the document now ready? Yes. So Docling has handled and our document is now in the done state. So the next thing up is that let's look on the chunks that the Docling created. So what we are going to do is we are just going to list a few items from there and check how they look like. Right now, okay, so in here we have our first chunk, looks good, looks like a paragraph, and we have our embedding there. And let's see the next chunk already. That's okay, it's there. So another good chunk, everything looks good. Maybe some bugs with section title and page numbers, but all in all it works enough well. So let's try next the search. So I'm just going to ask a question from the search and let's see what kind of answers we get. So I will be asking about the personality. So my personality type is ENTP. Nice acronym. Let's see how the vector search handles that. Dum-de-dum. Takes a little bit time. Everything is still fresh. Okay, so our first result, it's good. ENTP, that's what we expected. And let's see the next result. Okay. Oh, no. Allowing ENFP. So this is the problem essentially with vector search, and also it comes in here. This is a hybrid search. Essentially like for vector embedding, ESTP, ENFP, ENTP, these kind of acronyms, they look very close to each other. So this is kind of the problem of vector search. It's good on finding semantically similar text, but it's not so good if you really have to get that term exactly to be right. Okay, so the next thing up is let's try the chat. So in here I have already wired the simple RAG server to be the connection point, and let's start by asking a simple question. I'm interested to learn more about my bridge personality test. And we have our prompt going on, and right now I would guess that our essentially RAG server is doing its work and getting content, and now we get already our answer. The answer is, it is what it is. And I think that this is because we got a lot of chunks about the MBTI, because, well, we have the one document. But let's see what actually happened on the background. Let me get the window right in here. So you can see in here, okay, so that was the last one. Okay, so in here, yeah, I'm interested to learn more about Meyer bridges, and then we had the term extraction there and applied the boost term Meyer bricks, and then we got the results and generated the prompt, the context for the LLM. Super. So this more or less works as it should be. Now let's try a little bit trickier. Let's ask about ENTP and let's see. We remember, we got the bad search results, but LLMs can also sometimes fix these things by, looking at all things and looking our questions. So in this case, even though our search doesn't work, the LLM worked quite nicely. And actually it's quite correctly in here. So I am a little bit disorganized and impatient and stubborn and overconfident as a personality, which makes maybe a good architect sometimes. Now let's ask a little bit different question. What kind of career would work for me? So this is a typical question that you would ask in the chat, and the problem in here is that the prompt didn't contain the acronym, right? So the LLM didn't get from the context on what is our type, and it got the answer completely wrong because essentially it got wrong context. So in these kind of cases, the rack kind of architecture can get things wrong and actually produce less value than it should. But what can you do? We will fix this later. So at this stage, our simple rack server works as intended, works in quotation marks. The infrastructure is fully set up. We have OpenSearch, Docling Serve, EmbeddingGemma, and Granite all are up and running. The service offers basic functionality and hooks into the core services. That means the backend is wired to handle key tasks efficiently. Most importantly, our OpenAI-compatible API is operational. It successfully retrieves information based on your content, trying to gather the pieces of our architecture. Now, what's next? First, search capabilities could be enhanced to provide more precise, relevant results. As users interact, more advanced retrieval logic can really improve the experience, as we know that. Another idea, chat context management. Adding this would allow our server to better track user conversations, making responses smarter and more personalized. Finally, we might consider post-processing user queries. This could include steps like cleaning up prompt phrasing, reformatting input, or performing additional NLP, all ways to boost the quality and usefulness of our answers. So, with the server working, our priorities shift to fine-tuning these features and exploring new enhancements that will take the platform even further. Super. Thank you for watching my presentation. Let's see where things go. I hope to come back and share some more work in this area as soon as possible. If you enjoyed this video and want to see more practical coding and architecture projects, please hit the like button and subscribe to the channel. That way you won't miss the next build. Until then, take care and stay curious.